Hello and welcome. I'm Bill Wake. We're here working on an Elm interpreter written in Swift. We've been at it for a while and we're up to the point of working on function calls. We got basic function calls working, but function calls in parentheses got a little bit hung up on the grammar, so we're going to focus there today. Okay. So I ran the tests and we left off with one failing test, which is this one. Parenthesized expression may contain a function call. So here we have a lambda expression inside parentheses, and it's got its argument 3. So theoretically, lambda x goes to x, applied to 3 should be 3, and that should be perfectly fine with parentheses. Let's see, we'll pull up our to-do. All right, so parentheses are trickier than they look like they ought to be. One reason is they also notate triples with parentheses. So if you have parenthesis 3 comma 4, that's a tuple, a duple in particular, just 2. It's like an anonymous record that has these two values in it. Elm's funny to me anyway, in that it only allows duples and triples or truples. I don't know what they call them, but you can have 2 or 3 elements, but not more elements. So those are in parentheses. So when you see left parenthesis, it might or might not be a normal expression. It may be a list of expressions. The other challenge is, and we've barely bumped into this, but operators generally have, well, there are a lot of infix operators, but there are also prefix versions of those. So if you take parenthesis plus parenthesis, that's a function that takes 2 arguments and it returns x plus y. So we haven't even dealt with that one yet. Maybe we should do that as part of this or just after doing this. We haven't dealt with these. Well, we tokenize multi-character operators. I think I didn't record that somewhere, but we don't handle prefix operators. So today we're going to get this parentheses thing at least started, I hope working, and we'll go from there. So let's find that test that failed. All right, so we expected to get lambda x goes to x with 3 in a list, and instead we got an error missing right parenthesis. And this lambda may or may not be wrapped as a closure by the time we get it. I'm neutral on that, but clearly it should not be an error missing right parenthesis. Okay, line 1, column 12. So let's find the place in the parser we deal with that. So here's parenthesized expressions. Shrink this a little. All right, and so it's a parenthesis followed by expression followed by those braces mean 0 or more. So we can have parenthesis expression comma expressions. Well, we wrote the S's in there last week for expressions. Right now it just handles expression, as you can see on 155 here and again in 163. So the while loop corresponds to that 0 or more. While you see commas, you must have more coming. And this corresponds to the original expression. So we skip over parenthesis, look for an expression. If there's commas, we keep looking. And then at the end, we skip over the right parenthesis. Okay, now, in these usual ironies, well, what we have going on for expressions, which gives you a list of expressions. Let's see, what was I expecting? I was expecting a function call. Well, that's probably okay. Let's find our expressions. Okay. Notice the return type here is expression array. And at one point we had a multi-expression list or something like that represented a subtype of our overall expression type. But right now we changed it because it really just returns an array, and then the caller's got to deal with it. Here's function definition. Let's see, where's expressions? I guess up a little bit. Function call defs or defs equals expressions followed by equals expressions. And we call expressions and get the left-hand side. It's a list, and then we deal with it. Yeah, I don't know. There's a story about Oscar Wilde. I probably misremember it, but he's talking to this woman about how hard he's working. And, I had a rough morning. I put a comma in, and then an even harder afternoon, I took it back out. And we may find ourselves in that same position here that we added the type, we took it out, and now we kind of wish it was back again. Um, all right. So where's our parenthesized? We know this needs to be expressions, and we know that if it is, this will never be error expression. So how do we get the error expression from expressions? Well, we look for it. Um, we say, is any child an error expression? And then there's an error. So I think to pass our test, we're going to copy this, and we'll decide later if we should refactor. All right. So parenthesized expression should look for expressions. We'll paste this in. I'll comment these two lines out. All right. So I'm expecting well, we'll let, just to make it compatible, we'll say let expert equals oh no, we'll have to adjust that too. Okay. So if we go grab a list of expressions, we return an error if there's any errors inside it. That's legitimate enough. If there's no errors in that, then we want to gather these things. And I think in this case, expert is now LHS. No, that's not true. Well, maybe I'm going on a bad path here. Maybe there's a lot of work that's going on. So somewhere there's something that looks and decides it's a function call. Or not. Okay. So here's function caller definitions. We get the left-hand side, we make expressions. If the token has an equals, then we turn it into a function definition. Otherwise, we decide if it's an LHS, if it's a one-item LHS, we just return it. Otherwise, we make a function call out of it. Okay. And again, I'm going to take this. It's a little different situation. So I don't know, maybe we I don't want to return it, but I'm going to say let expert equal it. Okay, so if it's only one expression like we originally had in our original version here, then we're just going to, if it's not an error, we're going to return that one expression, assign it to expert. If it's multiple expressions, we're going to treat it as a function call. And then the first expression is here, that's fine. Okay. Now, that looks legit to me. Let's see if it passes the test. I think it will pass this test, but not every possible test we would write. Not even that. Okay, what do we got? Oh, a different test failed. Interesting. Oh, well, that is not really a legitimate error. It is an error because numbers aren't functions, or they certainly aren't functions of one argument. you might make an argument that they're a function. I'm gonna say let's make this a TBD for now, and I don't think it's Well, is it? It should be an error. I agree there. I don't think the error is a missing right parenthesis, though. I think the error is you've called a number as if it were a function. And let's just run and see how we handle that now at the top level. No parentheses involved. Okay, so if I just do 3.0, 4.0, evaluate that, somebody should be unhappy. A known function cannot be called. Let's change the message, the expectation. Oops, that's not what we want. Cancel. Let's look for this error. Error messages dot function can call must have function. I think that's true. A non-function cannot be called. That feels like the right message. Okay. Uh-oh. Location. Is that all? A non-function call cannot be called in line 1 is not equal to function call of 3.4. Well, this is just parsing, so it's a little tricky to get right. Okay. And the error should come when we evaluate it. But we're just checking the parse. So from a parsing point of view, I think this is legitimate. All right, let me go back to my TBD theory. Maybe okay from a parsing point of view. All right. And let's find that parenthesized expression one again. Let's see, this one is correct. It does find the function call properly. Why I said it's only partially correct, though, is we only did the first one. We didn't do the ones in the loop. So if we had something like, well, let's make the next test. This one's after a comma. So let's put in 42 this. Well, what should this be? I think it should be a tuple. We would expect a tuple with an integer value of 42 and a function call. Let's get these lined up. A function call, lambda expression, close the tuple, got to put a bracket in there. And I think I'll just do it like that. All right, and then we need a type. Well, we'll borrow this. Elm type tuple type number, and this is also type. Well, let's make this a float value just so we float. Okay, and one more paren somewhere. That closes the lambda. That closes that. What am I missing? I don't think there's just one more paren, right? Is there? Oh, yeah, for the check. Okay. Yeah. All right. Now this one I expect to fail. And I'm not, well, I think float value is right. But it should fail because we only handle the first one in our parenthesis handler. Okay. So we expected the 42 function call. We got error missing a right parenthesis. Yeah. All right. So, yikes. So again, this code basically repeats and replaces this because we're gathering all these into the tuple. And maybe I should maybe I'll have to do a little work there, but I think we're going to take this out, put in something more or less like this. LHS is really not correct, but that's okay. I guess let's see if we're working and then deal with it. But at the end here, we're looking at these results and deciding if it's a single value, in which case it's just a parenthesized expression and we return it, and we just return the item inside the parentheses, or it's 2 or 3, it's a tuple, and otherwise it's too many values in the tuple. Okay. Okay, so I believe this should pass. I realize there's duplication galore. Yeah, so much for my beliefs. Okay. May contain a function call after a comma. All right. So we got 42 function call lambda x variable x 3.0 is not equal to that. Perhaps the types aren't equal because we don't get to see those in this view. Let's well, a tuple, let's see how it writes things out. As string, just the inner values. Okay. Let's break here. I just want to see what these, if the types are the issue. Run this one test. All right, we'll step in. Okay, if I print expected, what the print expected. Oh, a little too much help there. Okay. The expected has type functions generic. Oh, maybe it's coming back generic. That's because this argument the result type is generic. So passing in a float, I think we're getting back a generic. And let's print, I think it's just parser.parse. Cannot find parser. Cannot find parser in scope. Okay, let's change it to generic. Is it 186? 5. For now, I think we're not quite enforcing the types correctly with generics. We haven't dealt with those, but we'll give it a try. So we bubble types up, but we don't bubble them back down. I'm still going to fail. Okay. Function call lambda x. I think the bodies and everything is okay. I feel like that should have a space after that comma, but okay. Well, let's modify parser.parse so we can take a look at it. And it's probably a good way to do it in these helper methods because we're likely to fail inside a helper method at some point, you know. So I don't feel bad about doing this. Back here. Okay. It is a bit of a flaw that we're not explicit about these generics. I'm sorry, explicit about the types on these expected and actual. It's embedded in the equality test. All right, so we'll step. Oh, maybe I didn't step far enough. Huh. Okay, now we can print actual. Okay. Generic, expression type X, WHM expression. Sorry, let's see if we're in the right right thing. So we got a tuple. Type is tuple. 0 is a number. 1 is unknown. Expression type unknown is actual. WHM expression is a tuple with 2 values. The type number, which is right for this one, and unknown, which is odd to me. I would have thought this should be coming from there. So it sort of sounds like, well, let's do a run. We'll try this at the top level. I don't know if we can, but lambda x goes to x applied to 3. Do we get an unknown or generic or what? We get a number. This seems odd to me. So now lambda x goes to x applied to 3. That all should be a simple value, not a comma list issue. Okay, so that's pretty consistent. Let's try 42. Lambda x goes to x 3. Evaluate. Number unknown. That's really odd. It evaluated the 3 correctly. But the type is not right. And the printing is a little funny. Let's run a real REPL. REPL. No, they print it with no spaces there. Okay, I guess we're imitating them. Looks a little cramped. Okay. So that definitely is weird because evaluating it on the left, it knows the type is number. Lambda x goes to x with 3, which is correct. And then inside parentheses, same deal. Let's try it the AB way. Lambda x goes to x of 3 applied to that, and 42. Put it on the other side. Okay, it's consistently coming back with unknown function call. And it may be unknown at this point. That's the hard thing for me to get my head around. He definitely should be Elm-type.number. Okay, Elm-type.number corresponds to the 42. That's correct. Elm-type.generic corresponds to the function call. So something is going on differently in the function call. I don't know. It's like something's going on differently in this than it is in our top level one. Definition 1. Okay, so here we call expressions. We look for errors. We don't have an equal, so that skips. LHS.count is not 1, and it makes a function call of the left-hand side. Let's see what function call does. Maybe, well, he does an unknown here. I guess that is. I mean, evaluating definitely deals with it. But you would think if the first argument, this is a function call, it may be, we talked last time about currying, where you just have the function with no value and it sort of defers and waits till you give it an argument in some other context. So it could be a function with no, that takes one argument, but the argument isn't there, so it just returns the function itself. I think his type should be. Wow, it's hard to know. I mean, it's supposed to be a statically typed language, right? So it must be knowable somehow. But I think, well, let's say where we are now is we're treating function calls as unknown until they're evaluated. And let's reflect that in our parser, I guess. Type unknown. Okay. It's there may be something with the tuples, the evaluation of the tuples that counts for this. No. Is not equal. Let's break there again. Function call 42. Function call lambda x, variable x 3.0. Oh. that. Oh, this should be here too. Well, if it comes back float, I'll get to complain. Okay, I'll just continue. All right, now let's evaluate it. Let's run it. Whoops. I don't know if I can paste that again multiple times. Error, missing variable and lambda expression. Line 1, column 8. 1, 2, 3, 4, 5. Oh. Yeah. Oh, you get one shot. Okay. 42. We don't need to double the lambda, the backslash. And evaluate that. Unknown. Okay. We're consistent with the way we're evaluating. Whether that's completely correct or not, I'm not as convinced. Let's look at tuple.evaluate. Yeah, it evaluates each one into its type. Okay, I'm going to record that as a bit of an oddity. Let's see, lambda x goes to x applied to 3.0 yields 3.0 of type number, but of this is type float, but this unknown. Okay, I definitely consider that an anomaly. Let's try one more. Well, it was lambda x goes to x 3.0 comes back float. Put it in a tuple, it does not come back float. That's just weird. Okay, so something's going on. Well, I think we're making progress. Yeah, I shouldn't be too quick to claim it. 2021-03-23. Story function call. Function call inside parentheses, even in tuple. Okay, I think we're doing that. At least, I mean, at some level. I guess I want to pursue this weirdness a little bit for a moment. That's capital F. Okay. It appears there's some difference between evaluating a top-level expression and evaluating it inside a tuple, and that makes me a little worried, a little puzzled. Okay, so we believe in the case of a top-level thing, it's function call or defs, we evaluate that to a function call. So let's look at how function call works. His evaluate. He's taking the context. Well, there's something about closure going on here. Function evaluate. just don't know. And we're passing in a function call with a symbol table. We don't have any free variables, so the symbol table doesn't really matter. Expression 0 is the function. What have we got here? Expression 0. We map each value. Well, the type. It's hard to know what's the right path to go down, I guess. So that's part of my thing. Am I just wasting my time on something we don't really quite address, or are we hitting some kind of weird thing that really is in our way? I'm not sure. All right, so in our parser test, we say you give me back a function call. Lambda expression. Function call is a list of stuff. All right, and then when I evaluate tuple, I create a new tuple. I take all the values, which are, well, it's a list of things, right? It's a list of expressions. Make sure that fits what we have. Our tuple is a list of expressions, an integer value, and a function call. So those are the values. And to evaluate this, we take those values, we run each one through evaluate with the context, and the final result is the type, which may or may not be correct. But evaluate, in our the integer value is fine. The function call, we're going to call evaluate the function call. So the inner thing here, and here's function call. How do you evaluate yourself? Well, you do a bunch of stuff. Expression sub 0, that's a lambda dot evaluate. Let's see our parser test for just a function call situation. No, we're expecting function call variable. Okay. Do we have a lambda function call? Well, I don't think we have an example. We don't have exactly this example. Let's see the interpreter stuff. Okay, so you got lambda expression n goes to n, pass in 42. Very similar to what we're doing. We say when you evaluate this, you should get back 42. Okay, that seems correct. Evaluate non-function first. Function call must have a function. Yeah, that's what we looked at before. Evaluate a function with no arguments. That's the currying kind of thing. If it doesn't have enough arguments, we return a closure ready to go for future evaluation. Okay, that makes moderate sense to me. Functions with multiple arguments should evaluate. Lambda x goes to lambda y goes to y, so we want to see the second argument, and we do. Okay, those look good. I think we'll leave this as an anomaly for now. This one, I think we handled already, so I'm going to move it down to last last week's stuff. Did we deal with it there? 16, 17, 18 function call. Yeah, it's always 0 or 1. That's a true thing. We talked a little about that. Okay. So I think we've made progress on this, even in tuples. This is an oddity that I don't know if I want to address just yet. Part of the problem is, well, I don't know if it's a problem. I'd like to get to real functions, and we don't have the capability because we don't have operators yet, and we don't even have functions that take 2 arguments that we could treat as operators. One way would be to go handle these multi-character operators like parenthesis plus parenthesis of xy goes to x plus y, and we could predefine a function for that, and that would be okay. Yeah, the other one we didn't do. This type of the lambda is constrained by what the expression does. We know type of 2 is number. And if a number is going to mix with something, it can mix with a float or another number. Or an int, I guess. And there's rules for that we should be bubbling the type down as well as up. And that's a confusing thing to me. Generic types must be constrained. Need a unification algorithm. Okay. 1 argument functions with lambda. We've been doing that. I think this is redundant to what we did. I think error checking on a function call we did. We did some of. I think we did what we intended. All right, how to handle multi-argument functions. That's really not an issue. That's dealt with by this currying thing we did implement. This generic type must be constrained, though. That really is a true issue. And these, I think, go away. Again, the stuff we did just sort of makes those irrelevant questions. So what would teach us something at this point? All right. I'm tempted to handle expression with operators. I'm tempted to do some of these prefix operators. E.g. this. And that would kind of let us deal with everything in our tuples. The other thing is, I guess I didn't really clean up this stuff. So let's clean this up. I don't think we're obscuring what's going on by cleaning it up. The bad thing is, well, we have duplication, right? We've got this expression, these 3 lines or 5 lines are pure copies from the other place. The only difference is the other one has to allow for a definition in the middle before this evaluation. Now, expressions. The other one that popped in my mind was, what if this thing returned the list of expressions and any error expression? Is that better? I don't know. I mean, if this only occurs once, I'm kind of okay. and maybe we can do this. Like this is, well, no, we still end up with an LHS and an error. We just return the error. Well, maybe this is a thing. So the case we got to watch out for is the function definition. Okay, because an example is you can say function of xy equals x plus y. I mean, we can't handle it yet because we don't do plus, but that's a legitimate Elm expression. And what we'll come back with is a function call with those arguments applied. And maybe that's an okay thing. Like maybe the function definition should take this and notice if it's a function. Well, we don't even have to care because it'll be a variable by itself or it'll be a quote function call. It sort of is like that. Maybe we can make this be what goes in. So the result of this is either I'm kind of moving stuff back into expressions. If expressions returned and a single expression, which was either a function call or a single value. Let's make that happen. Okay, so I'm gonna say, how do I get it back out if it's not? LHS is a list of expressions. All right, suppose let partial result equal that. Okay, we don't know what that means. Okay, but we're computing that from the stuff up here, which is okay. It's a little premature to call it a function call in a way because normally that means the one we're going to interpret, but we have this definition. It looks like a function call in the definition, so it's not horrible. And then if I said LHS, let new LHS, okay, work with me here. All right, actually I see we've gone quite a while without a break. Let me leave it here. Let's take a break. I haven't broken anything. I've just created an unused a value nobody's looking at. And we know it's legit because you must have at least one expression, so there's no problem here. So take a 2-minute break. We'll come back. I'm nudging this into the same shape as the code below so I can extract it once and then use it. So I think it'll be progress. But what I'm going to do as an interim step is I'm going to peel apart the result, the partial result, and then wrap it back up just like it was before. So I can pass it to function definition. Okay, so we will pick up there and see how it goes. All right, 2 minutes. All right, welcome back. All right, so let me reiterate what we're doing here. So what we have is down in our tuple, we have expression. We assign expressions. We check for an error, and then we use the fact of whether it's a one count or more than one to decide if it's a function call or just a simple expression. We have this code here, identical to this code here. Okay, and very, very similar to the code up here. All right. Before I added this line, we had 2/3 of the code here and then the last part here. So we have 3 solutions. 2 of them are copies. One of them is almost a copy, the two that are copies are derived from the original one. All right, so what I'm trying to do is what I call harmonize. So I have three solutions that are not completely identical. I'm going to push to get them identical, even if it makes some problems elsewhere to compensate for that. I'm going to feel like I'm ahead at this point. Okay, so here, I think I could say return partial result. All right, and I believe that is a refactoring. Okay, I'm still keeping LHS around, just the list of expressions, and I'm using that in token equals case. But partial result is calculated here. So this is progress. Okay, so now I've got these three lines, well, these 5 or 6 lines. They're identical. At least, I mean, modulo return or something, but they return a value, they represent a value. The problem is right now LHS is still used in here. So I would have to return both LHS and partial result. Down here, LHS is not referenced beyond this line. Okay, we use expression in here, save it, and then we recompute expression again, save it again. But we don't use LHS after the point where we reference it like in 180. Okay, so they're not quite the same. All right, but I can compensate for it, and I don't know, that may be ugly, and that's okay. Let's see. Where'd my function call go? There we are. All right. So now I would like to calculate, given partial result, can I reconstruct LHS? That's my goal. Okay, so now if can I ever have a function call there? What if I do I'll just call it array equals well, okay, I gotta say something. How about if partial result is function call do something else, do something else. Okay, so I'm going to make an array of expressions, because that expressions, that's the type coming in from LHS. Let's confirm that. LHS is an array of expressions. Okay. Expression. All right. So if I only have expected member name or constructor call after type name. Okay, let's convince it to be right. Okay, now I don't know if I can assign it as an array. Well, let's try this. Array equals partial result. If there's only one item, then the array equals that. Okay, I got to make it a var. I wondered if it would notice that both branches are going to do the same assignment. Otherwise, array equals, well, how about if let function call equals partial result as function call? Okay, if that's the case, then I'm going to say array equals function call dot expressions. Okay, so a function call just wraps an array of expressions. So it's given the array when it's called, doesn't look at it, it just wraps it. Okay, so we're going to pull them back out. I know this looks a little ugly, but I think we'll be okay. Was written to but never read. Okay, now I would like to use array here. Okay, does this work? Okay, now, okay, at this point, there's no reference to LHS after this line. That means that our behavior in both cases is the same. Okay, so what I want to do is, there are only 3 calls to expressions. I would like to make all of them do the equivalent of this at the end, and then remove that extra stuff. Okay, so I'm probably going to break a bunch of tests, but LHS equals the expressions, okay, is what got returned from expressions. Okay, so here we're parsing one expression, and if we find more, then it's a function call. Basically, if we have function 3, 4, we're going to find function here and then 3, 4 beyond. And sorry, usually I mute that. All right, so the problem now is the return type is not correct. This, we want to move it back to being just expression. Okay, and so we can return partial result. All right. Now, there's 3 places in our code and presumably at least 1 place in our tests that care about this. Let's find the places in our code. So who calls expressions? All right, here's one. So we would like expr, the value that comes through, to be equal to expressions. And then we don't need this stuff anymore. Okay, so we moved this code into the bottom of expressions. Now we're just calling it. So it's as if I inlined it and then re-extracted it with more stuff in it. And that's what I would do in Java, where I've got the tools that let me do that. But here, expr is again the result we want. So expr is going to equal expressions. This code that happens at the bottom of expressions now is fine. Okay, that's the tuples. Where's our function call? Did we do that already? No. Okay, and here they're working with partial result. And again, we'll fix names and stuff afterwards, but this stuff is no longer needed. All right. My claim is that's a refactoring. It's awkward the way we did it, but there may be some tests that call expressions directly. I don't know if there are, but if there are, they're going to be broken. Okay. Missing a right parenthesis. Oh man. Okay. I'm unexpected. Oh, we got unexpected character. The problem is I never know what's the. No, we expected unexpected character. Got missing a right parenthesis. Oh, okay. So, what I want to do is revert, and I'm realizing like, hey, you forgot to check in, you idiot. So, and it's in this. The function call case seems okay. Let me make sure I didn't do anything funny in the tuple case. Okay, so tuple, it did expr equals that, and then we did that. Token is comma. So we had a comma. The test case is comma. We eat the comma and we get the next thing. We got a right parenthesis. Let's run that test case here. I'm very close to feeling like I should just revert those changes though. Run one test case. It should come back with a right parenthesis. And the message was... Okay. So let's see token. Token is a right parenthesis. Expressions. How could that be different? It should call expression. What happens on a right parenthesis? Unexpected character at start of expression. Okay, well, let's see where we are. I will step in, over, in. Now I'm looking for expression. Okay. Let's look at token. Should still be a right parenthesis. Let's skip over token. And we get unexpected character. We'll go out. Okay. I didn't mean to do that. Well, let's see what expr is. Well, that's a darn floating point value. Let me start again. Sorry. Okay. Okay, we've read the front half. We're stopping right at the expression. So we'll step in and over and over. Now the expressions is an error expression, unexpected character. That's the right thing. Okay. The token is end of file. Can end of file start expression? No. So we should skip down to 119. Okay. The expressions has unexpected character. Okay, somebody's swallowing an exception. That's what's going on here. An error. I'm suspecting it's tuple. Okay. Let's see what error is. It should be the same one we had. Unexpected characters. Okay, this is good. Go out. Now, yeah, we're not catching errors. Expers are an unexpected thing. Okay. All right, we'll step over. Tokenized comma should be false. Require a right parenthesis. Okay, now we're missing it. We should have checked up here if any of the children have errors. Okay, so did we do that before? Well, we kind of did. It's almost like we need this still. Did I cut too much? Okay. We'll take that breakpoint off. Continue. All right. I'm going to clean things up a little. Well, no, better not. Okay, expr equals expression. That can't be right. I guess these things we've done. So let me clean them up. Yeah. I feel like I probably shortcutted something somewhere, but this feels right. We get this, we check for any expression in the contained stuff and throw it out if it is, return that if it is. And we started off that way today. I don't know. I feel like there was a little sloppiness in there, Bill. Okay, and we had one more case. Expressions here. Well, we kind of need that same if statement, don't we? Except it's if partial result. Okay. Okay. Let me commit this. We've gone way too long. I don't know why it's not in my brain today to commit, but I didn't do any commits yet. So the story is function calls, and then what we've done is we've reorganized how expressions is called so it can be used by both function definition and tuples. Okay. Now, I think that's... Okay, that's progress, believe it or not. All right, but this stuff I think should be the job of function definition. Okay, so I would really like to pass in partial result and let function definition pull out the array. All right, so I'm going to do a different approach this time. Try and do a little smaller steps so I'm more sure I'm clean as I go or correct as I go. So one way to do this is to say, I want to pass partial result. I'm going to pass it in first. So I'm going to pass partial result in as an argument and add that here. Okay, so it takes expressions and a partial result of type expression. All right, and there may be a test or something else calling it, but they're not a lot. Oh, I gotta put the underscore. Okay. So this is sort of like add a function parameter kind of thing, but or I could theoretically inline and re-extract this. But let's take this now, and I want to do this. Okay. That is not used. Okay, but who's expers? Let's call this expr old, and I'm going to let expers equal array. Okay, so I'm going to actually, this maybe even ignore is better for now, but I'm taking the original argument, a list of expressions. I'm not using that anymore. I'm accepting it, but I'm calculating the expers from the partial result. Okay, which is all this mess. Okay. And now this, well, whoops. The caller, well, that should work. Okay. But the caller shouldn't need it anymore. All right, so I'm not using this argument, so I'm going to delete it and delete it here. Okay, so you can see little smaller steps, but now that it's unused there, it's unused period, and I can get rid of it up here. Okay, so now this is definitely nicer. Okay, that was a little comment. Okay, so before we had a bunch of handling for the error expression case, deriving whether it was or not. Now we just check it before we start using it the rest of the way. So we just call function definition with it. Now it's a mess. Well, it's messier, I should say. All right, but I think we can work with it better. Okay, because its situation is it wants a list of variables, and that's all it can accept. So yeah, here we're doing that. Right. So it may be function result. If it's a function call, I mean, we're definitely still undoing a little work. So that's a little obnoxious yet. And maybe I don't see a way around it, but let's back up a little. This one I think is done. Let's check out the one expressions. Okay, so LHS equals the expressions. I take that to mean I could just make LHS this. Whoops. Okay, another simplification. I believe that is equivalent. I calculated the expressions and then I assigned it to LHS. I could just calculate LHS directly. Okay, let's make sure this is good. Okay, now I calculate all this stuff and assign it and then return it, so I could just say return this. Now that's the thing we're having to peel apart, which is annoying. Okay. But I think in our case, in our definition, we're supposed to already collect these places. Let's see. We're supposed to look. Oh, anybody who's not a variable, that's a problem. Now, expers equals array. I can bubble that back the same way. Let's do that. Array, expers. That should be identical. Okay, now I want to say expressions equals if the function call is that, if then this colon that. And here if the partial result is a function call, then I want to do partial result as function call dot expressions. Otherwise, that. Okay, so am I willing to trust this? That I could have written this way in the first place. We'll test it. All right, and then sometimes I've seen it written like this, which kind of makes sense. Okay. If partial result is function call, then we do that, else that. Again. And then we're checking that everything is a filter. Okay, I can move this down because he doesn't come into the calculation of this stuff. Okay. Okay, and then this is that reduce expression. Okay, so we got the LHS. We got the RHS is formed from the variables in the left-hand side. And then we skip the first one. So we're saying function xy equals. We want that to be lambda x goes to lambda y goes to whatever the thing was. The value. Okay. I think this is, it's not. It's not perfect code. How's that for a ringing endorsement? All right. But I think it's doing the job. Let's save it. Okay. So we're making a function definition. Check expressions for a list of variables. Let's see, function definition require expressions to be a list of variables. Okay, I think that's that. All right, so we just did a moderate size refactoring, right? So I'll just add that here. Very manual. Let's see, make expressions, produce an expression rather than array of expression, and deal with the consequences. All right, that is what we did. Okay. I'm thinking maybe these operators are our next mission. It would be nice to finish off whatever parentheses need to do and finish. Yeah, if we could do that and then plug in a function, we could do a predefined function for plus, the parentheses plus, and then that'll let us test our lambda functions a little better. Maybe at that point we could get the types to be right. All right, so I'm taking this off there. Tokenize multi-character operators. We did that, I said, yes. Okay. All right, expressions with operators is different. We're just going to get them parsed. Okay. Tokenize and parse. Okay. Well, I think it's probably another good moment for a break. But I think this will be a straightforward change. Right now, we look at a left parenthesis and we just say return left parenthesis. And what we're going to do instead is we're going to say, look at a left parenthesis. If it's followed by any of the operator characters, even if we had like plus, 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 times, 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 parenthesis, we would treat that as an operator token, I think. And then we can deal with looking them up and stuff like that. But I think that is a good start, is do that at the token level. And then parsing, we can treat that as a function name, as if it were a function name like foo or fn or something like that. All right, so we'll take that break, a couple minutes, and come back and deal with these operators. All right, welcome back. Okay, so we're going to handle these tokenizing these operators. I just closed all those other windows because we just got a little backed up there, piled up. All right, but we're looking at Lexer and Lexer tests. All right, so the Lexer... Oh, how many times can I do that in my life? All right, so the Lexer is basically matching regular expressions, and it's just the basic approach that it's been used a million times, but we're looking for, we'll switch on the leading character of any token, and then we'll do whatever the regular expression says to match it if we can. So somewhere here we have a left parenthesis. Here we go. Single character token. Well, that's not going to be true anymore. Okay, so let's work on a test. So I think this will be an operator token. And I guess right after this thing, let's test left, what do we call it? A prefix operator. Let's do that. Check token. Okay, if we get this, we expect to see token.prefix operator with the string that. Okay. And this thing has nothing like that. All right, take care, Code Wrangler. See you tomorrow. Prefix operator, it's going to take a string and the operator. Do I have to even say what the type is? The name. Okay. So our test should compile now and fail, since nothing returns token prefix operator. Pretty safe bet. Okay, and we haven't broken anything else, so that's good. Yeah, we matched the left parent, and we would normally just not match anything else, and the plus would come up next, and so on. But we're going to short circuit that. All right, so now left parenthesis. All right, so let's make a function call out of this, and if we're lucky, it'll let us refactor, extract method. Whoops. Undo. Let's try it here, eh? Okay. And refactor. Okay, and this function will be let's call it left parenthesis. Okay. Where's it? Put it above. I never quite understood that. I must think backwards from somebody. Like when I extract, I kind of want it to go read top down. And I don't know. We'll add this towards the bottom here. Okay. All right. Should be perfectly harmless. That's fine. Now, single character thing, we can only use that in when it really is a single character. And same test that was failing. Yeah. Okay, so let's find that single character token thing. All right, so I'm going to do the equivalent of inlining this. Okay, and then that's all down there. Okay, so single character token of that is the same as this with token.leftParent stuck in there. Okay. That gives us a good starting point. Well, make sure it works before you claim it. Okay, one test failed. The right test failed. Okay. And yeah, I'm refactoring red, so I'm trying to stick to safe refactorings or simple ones, extract method and inline method, but I left everything else I inlined without deleting the method. Okay, so now we have a left parenthesis. We just matched it with get next character. All right, and just like these other ones, we're just going to look at the characters and decide what's up next. Well, if the character, whoops, indent that a little bit. CH is the running character. If that is a plus, okay, then we're going to do some work. All right. So if it is a plus, we're going to get next character, skip over the plus, and then we're going to say, I want to, let's see. So I'm going to have to, verify that it's a right parenthesis. So I don't think it's legal to just say left parenthesis plus and leave it there and then go off and do other things. You know, it's really requires a right parenthesis. So I think we can say require. Nope. Require. Nope. I thought I had something like that. Skip until, skip while. Well, let's say require right parenthesis. No, I don't want to do this. Well, let's do it manually. If the character is not a right parenthesis, then we got a problem. We got an error. Okay, and we're going to return token.error with a message. Messages dot probably missing right parenthesis. There it is. Okay, and what else? Need a location and starting location. Okay. All right. At this point, okay, we handle it if it's not there. If it is there, we keep going. We got to do a get next character. Okay, so our convention is we always leave the next character, the starting character, the next token ready to go. So we want to consume this character. All right, I think this should pass. No, it shouldn't. I didn't return my thing. Okay. We'll get a left parenthesis. Okay, let's do this. Return token dot operator, prefix operator with well, we know it's this. We'll start there. And starting location. Okay, so let's make this pass. Right. Okay. So now what I want to do is I'm maintaining, let's see, where is that calculated? So set contains keep while. I have this keep, and I don't know if get token is doing that. Token.append character. Yeah, so keep number. I got to do a little work to keep this value, but I want to do that. All right, so keep, we got token. Let's see where the token string is. Okay, so we're going to keep the list of characters. And let's see how we do it in digits. Yeah, so we do digits. We keep them as they parse through. And then at the end, we compute them. All right, so its token is legitimate to use, so we'll do that. Left parenthesis. So instead of get next character, get next character is there, gets the character and location, but we also have keep, which appends and gets the next character. Okay, so we're going to call keep on that left parenthesis. Instead of this. Okay, so we're going to say keep token. All right. And then we're going to do the same thing here. Keep token. Okay. And finally, that gets the character. If the character is not a parenthesis, that's an error. And otherwise, we're going to keep the token. Keep and token. All right. Should be no change as far as what we're doing right now. Oddly slow. Okay. So now I have token sitting there with all those characters in it. So I'm just going to take advantage of that and do string of token. Okay, and I believe that will wrap it in a normal string. And then we've got it sitting there in our operators. All right, so let's make sure we've done that. And you can see if we do a left parenthesis, all right, somewhere I want to make sure token is zeroed out between calls. I'm pretty sure that should be the case. Token equals blank. Okay, when you call get. Yeah. So we've got our left parenthesis. We handle a plus. Okay, so I'm gonna generalize. Let's generalize our test. Okay, this should work for plus 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 as well, which is a legitimate operator. Okay, it's going to fail. And I could have split it into two tests, but I think I'm happy with this. Okay, and I should get an error missing a right parenthesis. Okay. Right, because we assume there's only one plus and it should be followed by a parenthesis, and it's not. All right, so let's make this a little different. So if the character is a plus, we have a keep while. Let's find that. Okay, with a set of characters. So let's find the example. It'll be in the numbers. Keep. Well, keep while. Uppercase name. Okay. So here's that strikes me as odd, but okay. Here's the lists of stuff in a set, and we just say keep while, and we get all of them. All right. So in my case, I'm going to keep while plus. Okay. So I'm saying if I had a whole sequence of pluses, where's keep while? Okay, it wants the set of characters and it's going to keep them in token. All right, so let's just pass in a set with plus. Okay. And that should accept. Oh, that's why we did this. That seems a little odd. I gotta. Well, let's see if it works, and then we'll work on it. Okay, so I want to do a lookup of Swift set of characters example. Character sets, they aren't particularly something. That's my experience here. Not particularly common. Okay, I guess I can live with that. Character sets. Well, that would be somewhat handy. They don't tell you. Okay. Thanks. I just want a constant. Can be initialized from a set of. I don't want a predefined. Okay. I don't feel like I'm learning quickly enough here. Okay, let's just look at set as a constructor. I don't know. Is that did I misinterpret what has to happen here? Cannot convert string to set of closed range. Let's let operator character of type set of character equal plus. Will that work? Or is my keep while to... Oh, well, we want ranges. Okay. So I don't think this is going to work. Okay, there it goes. I'll put this back. Yeah, a little awkward. Okay. Let's try something else. Let's try plus dot map to $0 dot dot $0. I did actually. Okay, that seems. Oh no. Okay, it might work. No. Something was complaining. Cannot convert array of close type. Oh. It's a map. Gives me an array. Can I do set of this? No, cannot convert set of close range of string. Okay, it's a little ugly, but it's moving. All right, so we're going to grab all the operators in this list plus and keep them in our token, and then at the end we have our token, and that works. Okay, so now let's break this apart. Let's let operators equals this, and this can be operator set. Okay. Oops, I didn't use operators. Operators. Let's see if my types still match up. Or do I have to be explicit? Something's upset. Okay. String. Now, can I say okay, if the operator contains the current character. Oh, sorry. Has that been frozen long? Okay. Well, I bumped it a little. Sorry. Okay. What did I have before? Oh, man. If character equals plus. Okay. Let's. That's the old. So I'm saying if operator set dot contains character, is that what you do? Keep while Well, set contains where. Okay. It's a little awkward to work with that thing. If operator set contains something where $0 contains character. Okay. All right. Do your work. Oh, that should be an if. If operator set contains. Let's do it this way. So I'm trying to find out, do I have any operators at this point would be my question. And, okay. I feel like I maybe should be wrapping this function, but anyway, let's go with where we are. Okay, so I've got I check if I should be getting any tokens at all. If not, if I don't see any operators, then it's just a plain old left parenthesis. I'll return it and we're good. If I see that we contain any of the operators, I'm going to grab all of them and then make sure we have a right parenthesis and return the whole string. Okay, so now I think I'm ready to change yet again. Okay, maybe I can test all the operators at once. Would that be useful? Okay, so I'll put this back to just the single character, and then this one I'm gonna do every character that can be an operator. With all operator characters. All right. And this, well, we have a list somewhere. It's in our to-do because we did all these tokens before. Okay. Less than equals plus ampersand bar minus. Less than equals that pipe minus ampersand. What else was on that list? Less than, greater than, plus, greater, less than. Okay, that looks like we cover them all. Oh no, there's single character tokens. Single character only. Okay, equals slash dot percent star. Well, let me write it here. Percent star that slash dot. Okay, we'll put all these in our test. And we should get the same stuff back. You don't really get to use this horrible operator because you're not allowed to define your own operators anymore. But that's okay. All right, not equal to missing a right parenthesis. Okay, so it got the plus. It got our string of pluses and then gave up. All right, and let's just add another duplicated plus just to make sure that's it's not looking for specific characters or anything like that. I mean specific strings. We could have a list of legitimate ones, but I think I'm going to let it be a semantic error, not a syntactic error. All right, and then I think, given these are the list of all of them, let's put them in our operator set. Okay. Let's see if our test runs. And I think we'll refactor. We'll move these up somewhere near the top. Oh, what did I mess up? Plus less than equals greater. Oh, I left out a plus. We get the string compare for free on the enum type. All right. So we're going to handle all prefix operators such as plus. All right. This is just the tokenizer. So we'll just claim it that far. 23. And just the tokenizing. Okay. Parse it as a function call. We don't do that. All right. But that's where we'll pick up next time, which is tomorrow morning, Wednesday, 9 to 11:30 a.m. and Eastern time as usual. So thanks for joining me. I will catch you in the future. Take care. Bye-bye.